So for today's demo, I mainly use an open source code called BISO and also our CEETRON products. So the CEETRON products are mainly used for the finite element simulation and visualization. And the BISO code is used for the model optimization. And we also use the hooks exchange for the CAD import and also Polygonica for the mesh smoothing. And I will talk about that later. So let's look at our first example. So our first example is just like a 2D like a triangular shelf model like this over here. And then we have some loads on the top over here. And on the left-hand side, which is fixed. So we use our CEETRON Solve SDK to create a finite analysis solver. And this solver can directly read the Abacus IMP input file. And then after doing the simulation, it will write the results of strain energy density and the stress. And then we will send those results back to the BISO code. And the BISO code will, based on those simulation results and the certain criteria, and then it will do some optimization to remove some unnecessary elements. And then it will generate a new model, and it will send the new model file to our solver again. And we will and get some new results and send the new results back to the BISO code again. So basically, like this kind of like iterative process, eventually we will get a optimized model. So in here, we have a short video to show the entire optimization process of this model. And then for this specific model, actually we run 73 iterations. Basically, that means we run 73 simulations. And then eventually the weight of the model was reduced to the 40% of the initial design. And then in here, you can see how the weight of the model was changed during those iterations over here. And in here, you can see that we have an optimized model over here, and we can have a closer look about it over here. And in here, you can see that we have an optimized model, something like that. But you can also imagine that we cannot directly use this model for manufacturing or 3D printing. So that means we still need to do some post-processing about that. So usually there are two ways of doing that. One is we manually redesign this model in the CAD system. And the other one is we use some algorithm or software like Polygonica to smooth the mesh of this model. So, but for this simple model over here, I chose the manual redesign method. So basically, I just made some holes like over here, 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 and from the initial design. And then eventually we get our final design over here. So you can see that this is our initial design, and this is our final design from the generative design. Although this is just like a simple 2D like model, but it's evident that we couldn't be able to achieve such a model using the traditional design method. So this showcases the charm of generative design. It can produce diverse, reasonable, and innovative design solutions in a more efficient and objective manner. And also, we do the validation for the final design, and we get the maximum stress is 75 kPa, and it also meets the design requirements. So next, let's look at a more complex example. And for this example here, we have a 3D model like this, and we have some loads over here, and we have those points over here, they are fixed. So our goal is still to reduce the weight of the model to the 40% of the initial design, but at the same time also ensure that it meets the design requirement. So in here, we have several videos to show the entire optimization process from different angles about this model. And for this model, actually, we run 57 iterations, and eventually we get an optimized model and the weight of this model reduced to the 40% of the initial design. And also, we can have a closer look about this model over here. And this is our final optimized model we got. And you can also see that for this model, we cannot be directly use that for the manufacturing or 3D printing. But unlike the previous, simple model, it's difficult for us to manually redesign this model in the CAD system. So this time I chose using Polygonica to smooth the mesh, and eventually we can get a model which can be used for the manufacturing and the 3D printing. And actually, Polygonica is a great tool for this application. So over here, you can see that this is our initial design, and this is our final design we got from the generative design. So basically, this concludes my today's demo about how to achieve the concept of generative design using our tools. And thank you all very much for your time and attention.